Hello students, this is a question from JEE Advanced 2026 on the chapter Thermodynamics. It's a moderate level question. I will read out the question first. An ideal gas 0.5 mole initially at 2 bar pressure is compressed at a constant temperature of 600 Kelvin in two steps. First against a constant external pressure P bar where P is less than 8 but greater than 2, and then against constant external pressure of 8 bar at each step. The compression is stopped only when the pressure of gas becomes equal to the external pressure. The total work done on the gas in these steps is W, considering all possible values of P, which is less than 8 but greater than 2, and taking the gas constant as R in joule per Kelvin per mole. The minimum value of mod W in joules is, so we have to find the minimum value of work in this compression process. We have to find the minimum value of work or magnitude of work. So this is the isothermal process. In isothermal process, we have product of P and V as constant. So if I represent the graph for PV curve for isothermal process, the graph will be a hyperbola. So graph will be like this. So for this value of pressure, so this is on y axis we have P and on x axis we have V. So this is the hyperbolic graph. Initially the pressure is 2 bar. Initial pressure given in the question is 2 bar, and number of moles are also given. Number of moles we have 0.5 mole, and temperature is also given, which is 600 Kelvin. So initially pressure is 2 bar. Let's say initially volume is V1. So using ideal gas equation, we can easily find out initially the pressure is, this pressure is 2 bar. Let's say this is P1 pressure, where P1 pressure, initially the pressure is 2 bar. Applying PV is equal to nRT, we get this initial volume V1, P1 V1 is equal to N, number of moles 0.5, and RT. So we get initially the volume is RT by 4. And in this process, we have to use just 2 steps. So the process is obviously irreversible. So initially, we have to compress the gas at a external pressure of P. So this is the external pressure P. This value is not known. So we have to find this value for the minimum work. And in second step, it is given in the question that we have to compress the gas at external pressure of 8 bar. Here we have 8 bar pressure. So we have to compress the gas at 8 bar pressure. So this is the curve for this 2-step process. Both steps are irreversible. This P is unknown. Let's say here the volume V2 and here we have volume V3. So volume here is, finally the volume is V3. So using PV is equal to nRT, we have only unknown here is this pressure where the first compression is taking place. So we have to find the P. So we have P V2 is equal to nRT. So V2 is RT by 2P. And finally we have final volume V3, which is P 8 bar V3 volume is equal to nRT. So the final volume we have is RT by 16. So here we have only one temperature is known. I will put the value of temperature at the end of the question. So let's calculate the work. In first process, we have this much work done, this much. At external pressure P, where volume changes from V1 to V2. So work 1 is external pressure P minus P. So we have to take the mod anyway, minus P, and change in volume is this final volume V2 minus V1. And in second process, so I will put the values here. This P is a node, so I will put it minus P, and V2, we have V2 RT by 2P, and minus V1 is RT by 4. V1 is RT by 4. Next, in second step, we have work is equal to, in second step, the external pressure is 8 bar. So work in this process is this much work is done. So we have pressure minus 8 bar into change in volume from V2 to V3. So final volume is V3 minus V2 is equal to minus 8. V3 is RT by 16. So here we have RT by 16 minus, and V2 is, here we have V2 RT by 2P. RT by 2P. So overall work done, total work done is RT. So I will first multiply this here, negative and negative. This will be a positive values. We have RT, PRT by 4 minus P cancel out, RT by 2 minus RT by 2. In second step, we have work, total work, we have to add W1 and W2. So next, we have this value is minus RT by 2 minus RT by 2, and this value we have plus 4RT by P, 4RT by P. So this value is, work here is positive, as this is a compression process, so work is obviously positive. So mod will be the same value for mod of work. Next, I am taking the RT out of, or RT as a common factor. So we have P by 4 minus RT by 2 minus RT by 2, it is minus 1, and we have 4 by P RT plus 4 by P, and we have 1 minus 1 whole into RT. So we have this work. So find the minima. So in this case, we have to find the minima. At minima, this derivative between work and P will be 0. So we have to make dW by dP is equal to 0. So we have dW by dP. So P by 4, I am taking derivative here. So it is 1 by 4. I am not considering the constant because we have to equate it with 0. dW by dP is equal to 0. So constant, we do not have to consider the constant. And 4 by P, so we have P to the power minus 1. So its derivative is minus 1 into 4 by P square. P to the power minus 1, so it is minus 1 P to the power minus 2. So this derivative will be 0, and we have P square is equal to 16 and P is equal to 4. So this compression is happening at 4 bar pressure. So we have to calculate this value. I am putting P is equal to 4 here. So it is 4 by 4 1, 4 by 4 1, minus 1, 2 minus 1 is 1 RT, and temperature is 600 Kelvin, so it is 600 R, and so our final answer is 600 R. You have to, in this question, you have to just calculate this pressure at which this first step is carried out. So if you know this pressure, then it is a very simple question. Thank you.